Today we will be working on the following problem 3, giving a subset E of 0, 1 with a Lebesgue measure 1/2 and 5 distinct points in a set X, X sub 1, X sub 2, X sub 3, X sub 4, X sub 5, also in 0 and 1. Prove that there exist 2 points Y and Z in E and 2 points in x sub I and x sub j, such that y minus z equals x sub I minus x sub j. Pause the video if you want to work on this problem by yourself. Now let's prove it. So basically we want to find the two distinct points y and z in E such that this. So if we rewrite this, the 2 points we want to find, we can say like y plus x sub j equals to z plus x sub I, right? So now this gave us a hint, like what if we define, let's say define E sub I to be the translation of E, which is all the x sub I plus x, where x is in E, and then this I is 1, 2, 3, 4, 5. Now we can see, because this is a shift of this by the Lebesgue measure is invariant under translation. So we know each Lebesgue measure of E is exactly the same as E, which is 1/2. Right? So if you look at this from 0 and 1, and then some E here, and then we have some x sub I, x sub 2, x sub 3, 4, and 5, right? So now by shifting this, we know each E sub I, because x is from 0 and 1, right? So each E sub I is actually a subset from 0 to 2. So let's look at the union of this, all of this, the union of E sub I, 1 to 5. So what is the measure of this f? Clearly, because each E sub I is a subset from 0 to 2, this interval. So you union all of this, clearly this is also a subset of this interval, right? So the measure of f is at most 2. So now let's see if pairwise of this if any of this pair, like E sub I and E sub j, is empty, they are disjoint for all this I not equal to j, what do we have? If they are all distinct, then this measure would have been the union of all of this, because they each pair are distinct. So by the additivity of the Lebesgue measure, this is the sum of each individual one, right? And which is the each of mu sub I from here we know is 1/2. So this is 2.5. But we know this is at most 2. This at most 2. So a contradiction. This tells us there exists, therefore there exists a pair E sub I not equal to j, E sub I and E sub j is non-empty. So meaning, in other words, meaning there is some E in the intersection, right? And now, by the definition, if we go back to the definition of E sub I, we know there exists E can be written as x sub I plus some y. And then also x, because it's E also in E sub j, so it is x sub j plus some z, where y and z are in E, right? So now we have x sub I plus y equals x sub j plus z. This is exactly what we want. So y minus z equals to x sub j minus x sub I. That's it.